but we're going to spend our remaining 20 minutes reviewing now, and then we'll do one more class period, then we'll have our last quiz.
All that, just forget immediately how to do the first two problems.
All right, so yesterday we kind of focused on the things called quick review 1 and 2, and notice there's one more quick review. So let's take a look at it. This is quick review 3. It's on the back of what we did yesterday. And this has some different stuff on it. This has stuff from, other parts of the chapter. Okay, so here's my shape. Now your job on this problem is to write a sine equation and a cosine equation for this curve. Okay? Now, first of all, does everybody see potentially a sine curve and a cosine curve in this picture? Yep. Now, I don't know, what do you see when you just kind of look at it? What do you want to start with? Sine? I kind of think that too. In blue, I see a sine. Now, that is not the only sign that's in that picture, but would you agree it's a sign? Okay, so let's do that first. Tell me what you know. Remember, let's review what all these blanks do. This is our amplitude blank, height, and the height of this curve is clearly 2. Now, sometimes that can be a negative number, but not for me, because my sine, that part that I drew, goes up and then down, and that is a sine curve. It's not upside down, right? Okay, the number that goes here influences the period. This number is not the period, but it influences the period. This number actually divides the period. So I know that my normal period of a sine curve is 2 pi. But whatever that number is, I'll call it n for the time being, I've divided it by that number. To get this period, which is what? What is the actual period of this picture? From negative 1/6 to 3/6 is 4/6. Now I know that's not reduced, but it really doesn't matter. That's the period of this picture. All right, stop, digest that. You with me? From -1 to +3, Drew, is 4.
Yeah.
These are sixths. So that distance is 4/6. But it's supposed to be 2 pi. So we've changed it. We've divided by something. So to figure out what we divided by, you can either use your common sense, this one you can kind of logic out, or you can always cross multiply. Just remember, when you cross multiply, you're solving for n. So what does, you're solving for n. So what does n work out to be? 3. So this number is a 3. 2 pi divided by 3 gives me this period. Now what is this number for? Where it starts, it's a phase shift. So this one starts back at negative pi over 6. So in my equation, it'll be plus pi over 6. And then what's that? Vertical, but it doesn't appear that there is a vertical shift here. because I just going up 2 and down 2 right on the main axis. I haven't looked at it or anything. So you don't need to put plus 0 there. I did because I had a blank there, but you do not have to put that plus 0, obviously. All right, so let's stop right there. This is an equation for a sine curve. Now, when I go to do a cosine curve, the only thing that's going to change is that right there. And possibly I'll need a negative on my amplitude. So where is a cosine curve in this picture? Where do you see a cosine curve? Down here? Here?
Yeah.
Now that would be a sine curve. If you started here, that would be a sine curve. So you could start here. Could you start here? That would be one possible cosine curve. Remember, cosine curves start at the top or at the bottom, depending on which direction they're going. So would that vaguely pink marker there, would that be a cosine curve? Okay, so if I use that piece, which there are other pieces, we'll talk about it in a second, the amplitude is still 2, and is that pink one a positive cosine? Yeah, so it's positive 2. The period hasn't changed. Here to here is still the same 4, 6. What did change was, now I'm not starting here anymore, I'm actually starting at 0. And again, you don't need to put that 0 in, those zeros in if you don't want to. I'm just filling in blanks. So it's fine to have them there, it's fine not to have them there. Now, somebody else might say they want to look at this cosine curve. Is that purple thing a cosine curve? Yeah. If you did the purple one, then you'd have to put a negative here. This would still be 3. And now our phase shift, x minus, now I'm going to write 2 pi over 6 because I told you you didn't have to reduce it, but if you want to make that pi over 3, that would be great. But you don't have to. All right, are we good on that problem, guys? Find the exact value of the tangent of the angle whose sine is 1/4. This problem literally says, find the tangent of this angle. This is an angle. It's an angle whose sine is 1/4. What quadrant is that angle in? Don't look at this right now. What quadrant is that angle in? 1. So it's an angle in quadrant 1, and it has a sine of 1/4. What's the other side of the triangle? Do not say root 17. What is it? Y'all passed geometry somehow. This is the Pythagorean theorem, people. Come on. Root 15. Did someone say root 2? I'm going to pretend I didn't hear that. Root 15. Your side is root 15. A squared plus B squared equals C squared. Right? So that's root 15. Stop it. Okay. Now, what do I want to know? This is the angle right here. I don't know what it is. I don't need to know. What do I need to know about it? It's tangent. So look at that picture. What is the tangent in that picture? 1 over root 15. Or root 15 over 15. This problem is typable on your calculator. Tan second sine 1/4. Done. But it'll be a decimal. This is the exact value. Okay? Okay, so we drew a picture of the angle. Had to do the Pythagorean theorem to find the missing side. You're always going to have to do that. Might be a different side, but always have to find the side. And then we looked and said, okay, what's the tangent? Done. Got it? The next one, this is like the problems where we said, is this sinusoidal? And what is its period? This particular question only asks for the period. Okay, so who remembers how to do this? What do we have to do?
Find the period.
Find the period of each piece of it, right? So what's the period of this part?
Pi.
2 pi divided by 2, which is pi. Perfect. What's the period of this part? 2 pi divided by 1/3, which is 6 pi. Now, it didn't ask, but if it did, it's not sinusoidal, right? Because if it's sinusoidal, these two numbers have to be the same. Now, question is, what is the period of it? Well, keep in mind that when we say the period is pi, that means when I draw it, every pi, it repeats. Okay? So it starts over again at pi, 2 pi, 3 pi, and so on. This does. Now what about this one?
6 pi.
This one starts over again every 6 pi. So I didn't write everything out, but what would be the first number that is in both lists? 6 pi. So the period, the answer to the question is 6 pi. The period of the whole shebang is the first time, or the first number that appears in both lists. Find a negative coterminal angle for negative 10 degrees. Find a negative coterminal angle. What? Meg says negative 370 degrees, and she is exactly right. How do we find coterminal angles? Add or subtract a revolution. And if I'm in degrees, a revolution is 360. So a negative coterminal would be this. A positive coterminal would be this. Add 360, subtract 360. If that's a radian measure, then we don't add and subtract 360, we add and subtract 2 pi. On the calculator, type the sign of 5 pi over 12. How should our calculator be set if we're going to type in the sign of 5 pi over 12? Radians. Sine 5 second pi divided by 12. Hopefully you're getting 9659. 0.9659. The pi button is right over underneath your clear button. In chapter 5, we will learn how to do this problem by hand. But right now, the only thing we can do is type it in our calculator. Everybody get that? All right, last one on this page. In which quadrant are we? If the secant is negative, this means negative, and the tangent is negative. Which quadrant are we in if both of those are negative? What do you think? 2? I heard a 2. Let's look at 2 and see if that works out. In quadrant 2, I don't know any numbers here, but I know my rating, my hypotenuse is always positive. This would be negative and that would be positive. Do those signs make sense to you in that quadrant? Now, I'm interested in secant and tangent. Secant would be hypotenuse over adjacent, reciprocal of cosine. And tangent is opposite over adjacent. All right, so let's check it out. Hypotenuse over adjacent. Here's your angle. This is adjacent. Hypotenuse over adjacent, is that negative? Yep. Opposite over adjacent, is that also negative? You got it. If you guessed quadrant 2, you guessed right. Or if you logicked that out ahead of time, you got it absolutely correct. Okay? All right, next time we are together, we will review again